Hello everyone. In this lecture we are going to discuss about the Fourier half range sine and cosine series. Learning outcome of this lecture. One should be able to understand the even and odd periodic extension, how to write Fourier cosine and Fourier sine for the function defined over the interval 0 to c. Extension of a function. If fx is a periodic function of if fx is a periodic function over a period 2c, but it is defined only on 0 to c, that is on the half of the interval of minus c to plus c. Extension of the function is possible in interval minus c to 0, type 2 of the extension, even periodic extension and odd periodic extension. If this is the slide for the even and odd function, if fx is a function over 0 to 1, then the graph is this, where this is fx and this representing the x. Then even periodic extension of fx is converted as, if fx is a function of mod of x from minus 1 to plus 1, then this is the graph of mod of x. This is the graph of mod of x, and it is an even function. This is an even function because if we consider the y-axis as the mirror, then the image of right side is equivalent to the image of left hand side. So this is the even function. If the function is odd, for the fx is equal to x for the interval minus 1 to 1, then over here this is the value for 0 to 1, and for the minus 0 to minus 1 the function is at negative side. So this is the odd function. The image of right hand side is not reflecting as in a left hand side. So this is the odd function graph, this is for the even function graph, and this is just a function of fx. Now it is possible to obtain Fourier cosine and Fourier sine series for a function is defined on 0 to c, depending on the requirement of the particular problem. Yes, half range sine series and half range cosine series. For the interval 0 to c, half range cosine series is fx is equal to a naught by 2 summation n is equal to 1 to infinity an cos n pi x by c, as simple formula as we have discussed in the Fourier series, but bn is 0. So this is the half range. For this, bn is 0 and the value of a naught is 2 upon c integration 0 to c fx dx, and an is equal to 2 upon c integration 0 to c function fx into cos n pi x upon c dx. This is for the half range cosine series for the interval 0 to c. Now same half range sine series for the interval 0 to c, that means a naught and an will be 0. A naught and an will be 0. Bn series is fx is equal to summation 1 to infinity bn sine n pi x by c, and bn is equal to 2 by c integration 0 to c fx sine n pi x by c dx. Now consider one example. Find the Fourier series for the function fx is equal to e to the power ax for the interval 0 to pi, where a is a constant value. Now because we are going to find the value of sine Fourier series, so we have to just find out the value of bn. So bn is equal to 2 upon c, where we just compare this value with c, so that c is equal to pi. So 2 upon pi, 0 to pi e to the power ax as a function sine n pi x upon c, sine, for according to the formula sine n pi x upon value of c is pi, so it is just n pi dx. By using the formula of integration, that integration of e to the power ax into sine bx is equal to e to the power ax upon a square plus b square, where this is the a and this place we get the b, into a sine bx minus b cos bx. So we just use this formula to integrate the value. After implementing over here, we get a is replaced by a and the value of b is n. By using this formula, we get the value 2 upon pi e to the power ax upon a square plus n square into a sine nx minus n cos nx for the limit 0 to pi. Now substituting the limit, for the upper limit we have to substitute the limit for x. This limit is only for x because we are doing integration with respect to x. Now replacing the x with pi, we get e to the power a pi upon a square plus n square into a sine n pi minus n cos n pi as the upper limit, minus lower limit term is e to the power 0, that will be 1, a square plus n square, and again we are substituting the value over here for sine 0 and cos 0. Cos 0 is 1, minus minus plus, so finally this is the plus term and remaining value is n upon a square plus n square. Now because sine n pi is 0 and cos n pi is equal to minus 1 to the power n, so we get 2 upon pi n upon a square plus n square into minus 1 to the power n e to the power ax a pi plus 1. So finally the value of bn is 2n upon a square plus n square into pi and multiply by 1 minus 1 to the power n e to the power a pi. Now if we substitute, because this is the value of bn, this is the value of bn, when n is equal to 1 we get the value 2 upon a square plus 1 square into pi and 1 minus 1 to the power again 1, that will be minus 1, so minus minus plus 1 plus e to the power a pi, this is a1. Similarly substituting the value of n is equal to 2, we get b2. Now by using the Fourier series, fx is equal to summation n is equal to 1 to infinity bn sine n x n pi x by c. Because in this problem the value of c is pi, so the formula of Fourier series is substituting the value of pi, then it will be summation n is equal to 1 to infinity bn sine n x. Now we just expand this series for two terms and remaining term as so on. So this is the Fourier series, Fourier half range sine series for the given problem. If the question is given for the cosine series, for that point of view we have to calculate the value of a naught and an. If we have to find out the value of cosine series, then we have to find out the value of a naught and an, but over here it is required to find out the value of sine series. So just find out the value of bn, substitute the value in this formula and you will get the solution. Now one more question for cosine series. Next question is Find the Fourier half-range cosine series of the function ft is equal to function ft is 2t when the limit is 0 to 1. Function ft is 2 into 2 minus t when the limit is 1 to 2. That means the interval is 0 to c, 0 to 2. So when we compare this with 0 to 2 or 0 to c, because this is the half range, so the value of c is 2 over here. We get the value of c as 2 because we have to find out the value of half range cosine series. That means first we have to find out the value of a naught. A naught is equal to, according to formula, 2 upon c integration 0 to c fx dx. Over here substituting the value 2 upon the value of c is 2 integration 0 to 2, 0 to, we just say we are just splitting it, 0 to 1. The function value is 2t dt plus 1 to 2. The function value is 2 minus t dt. So we get, first we integrate the 2t, we get 2t square by 2 limit 0 to 1 plus the second value is 2 is common, 2t minus t square by 2 for the limit 1 to 2. Now the substituting the limit, we get t square for limit 0 to 1 and plus 2 into 2t minus t square by 2 for limit 1 to 2. So finally when we substitute the value for this quotient, we get 1 minus 0 plus 2 into 4 minus 4 by 2 for the upper limit for 2 minus lower limit, that will be 2 minus 1 by 2. After calculating it, we get 1 plus 1, that is 2. So a naught is 2 over here. Now we have to find out the value of an. So an is equal to, according to formula, 2 upon c integration 0 to c ft. Because the function is in the terms of t, so we just replace the integration from dx to dt. Cos n pi, instead of x we will just write t over c and dt. Now substituting the value 2 upon 2 integration, I just split over here. Instead of splitting it on a first step, you can say that integration 0 to 2 for ft dt. Now you can split it easily. The value is 1 into integration 0 to 1 2t into cos n pi t by c is missing over here, 2t into cos n pi t upon 2 dt plus integration 1 to 2 into 2 minus t cos n pi t upon 2 dt. Now after integrating this part by using the chain rule of the integration, we get t sine n pi t upon 2 upon n pi by 2 minus integration sine n pi t upon 2 upon n pi by 2 dt. For whole value, the limit is 0 to 1 plus For the next portion, 2 is just common. We have taken the 2 as a common. Then 2 minus t into sine n pi t upon 2 upon n pi by 2 minus integration of the differentiation of this 2t. We get minus 1 sine n pi t upon 2 upon n pi by 2 dt, and the limit for the second portion is from 1 to 2. Now again substituting and integrating these parts, we get the value of 2t upon n pi sine n pi t upon 2 plus 2 upon n pi whole square cos n pi t upon 2 for the limit 0 to 1 plus 4 2 minus t upon n pi sine n pi t upon 2 minus 2 upon n pi whole square cos n pi t upon 2 for the limit 1 to 2. Now substituting the values, we get 8 upon n square pi square 2 cos n pi by 2 minus 1 cos n pi is an. So finally this is the an. Now to find out the Fourier half range cosine series, the ft is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi t upon c. Now substituting the value, we get ft is equal to, the value of a0 is 2, so 2 upon 2 plus 8 upon pi square is common, and the summation n is equal to 1 to infinity 2 cos n pi by 2 minus 1 minus cos n pi into cos n pi t upon 2 is the Fourier series for the given problem. Now summarizing it, in this lesson we have studied about the Fourier cosine and sine series function of period 2c when it is defined only on the interval 0 to c. Concept of even and odd periodic extensions in minus c to plus c. Thank you for watching this video, and for any doubt and any query, please contact your concerned faculty, and stay home and stay safe. Remaining video will be uploaded on the same channel.